Okay, so this is part 1 of Module 4. And in Module 4, we're going to take up different network theorems that you can apply to linear circuits. So this is a summary of what we're taking up today. First, I'm going to discuss with you the principle of superposition. And then I'm going to discuss with you equivalence concepts when a circuit contains sources. If you will recall, nakuha na natin yung circuit equivalence dati, ano? But the circuits that we got an equivalent to were all resistive circuits. So now we're going to discuss equivalence concepts when a circuit contains both resistances and sources. And the first thing we'll take up is source transformation. Okay. The next meeting we'll continue this topic. Okay, so let's start with the principle of superposition. In a linear electric circuit, and don't worry at this point what a linear circuit means, no? That will later be explained to you. No? But in a linear electric circuit containing n independent sources, the current or voltage in any part of the circuit can be expressed as the algebraic sum of n components, each of which is due to each independent source acting alone. I don't want you to get intimidated by the definition. All this means is, for example, if I have a circuit, let's say this is a circuit, and let's say I have three, I have three sources. Let's say this is source 1. Let's say I have another source here. Let's say this is source 2. Let's say I have another source here. Let's say this is source 3. And then let's say somewhere in the circuit, I have a resistance. So let's say I have a current flowing through that resistance. Let me call this I of X. And let's say I have a voltage across the resistance V of X. No? Ano yung sinasabi ng principle of superposition? No? Ang sinasabi ng principle of superposition, I of X is equal to IX1 plus IX2 plus IX3, where this is due to source 1 acting alone. This will be source 2 acting alone. And this is correspondingly 3 acting alone. So the sum of your the total current, okay, or the current can be attributed to the individual contributions of each source acting alone. That's what principle of superposition means. And it's the same with V of X. V of X is the voltage with source 1 acting alone plus the voltage with source 2 acting alone plus the voltage with source 3 acting alone. That is the principle of superposition. A source is considered acting alone if all other sources are suppressed. No? So ano ibig sabihin ng suppressing a source? Suppressing a source is equivalent to reducing it to 0. So you hear either of the two terms. No? Either you hear, okay, the source is suppressed or the source is reduced to 0. No. Reducing an independent source to 0. So if it is an independent source, how do we reduce that to 0? If it is a voltage source, you replace it with a short circuit. That's how you reduce a voltage source. You replace it with a short circuit. How do you suppress a current source? You suppress a current source by replacing it with an open circuit. Okay, so that's how you suppress sources. Okay, let's jump into an example. So easiest way for me to explain this is to jump into an example. So here I have a circuit with two sources, two independent sources, Vs and I of S, my two independent sources. And I'm going to use the principle of superposition to determine I1 and I2 in terms of the circuit parameters. So how am I going to do this? So first, let's consider V's of S acting alone. No? So let's consider V's of S acting alone. If I want V's of S to act alone, I have to suppress my current source. And to suppress my current source, I replace this with an open circuit. So what is my equivalent circuit going to look like? Well, I'm going to have V's of S. Okay. I will have R1. I will have R2. And then my current source, I replace that with an open circuit. Okay. I replace this with an open circuit. So let me call this current now I1A and I1B. I1A, I1B. I1A, the current through R1 with V's of S acting alone. I1B, I2, I2A, not I1B, I2A. Okay, I2A, the current through R2 with V's of S acting alone. No? So now this is an open circuit. Okay. You will notice that I1A will be equal to I1B. No? Will just be equal to V's of S over your total resistance, R1 plus R2. Because if this is an open circuit, then what we have now is just a single loop circuit. And in a single loop circuit, you only have one value of current flowing. And that current is the voltage source divided by the total resistance in that particular loop. So yun yung, this is V's of S acting alone. Okay, so that's the first component. What is the second component? The second component is I's of S acting alone. So if I's of S is acting alone, we replace V's of S with a short circuit. Okay. So what is our equivalent circuit now? So now this is a short circuit. Yan yung V's of S natin. Okay, this is R1. This is R2. Okay. And now I have I's of S. This is now acting alone. Okay. So now this is I1B. No? This is due to I's of S acting alone, and I will call this I2B. I1B and I2B. Okay. How do I determine I1B and I2B? Any suggestions? Any suggestions? Just shout it out.
KCL po.
Yeah, you can do KCL. Any other suggestions? You can do KCL, no? So pag nag-KCL tayo, sige, let's do it by KCL. Okay. You have I1B plus IS is equal to I2B, no? Or IS is equal to minus I1B plus I2B. However, if you take a look, I1B is actually equal to negative Vx over R1. Now, I2B is straightforward. I2B is equal to Vx over R2. Therefore, if you substitute this back, you're going to get IS is equal now to Vx over R1, no? Dahil negative. So Vx over R1 plus Vx over R2. No? Or this is just Vx 1 over R1 plus 1 over R2. No? So you can solve for Vx. Vx is equal to Is. Is times R1, R2 over R1 plus R2. Now, if you know Vx, okay, if you know Vx, we can now get I1B and I2B. No? So again, feeding back into these equations, okay, you have I1B, okay, is equal to minus Vx over R1. No? So this is minus IS R1, R2, but over R1, no? So R2 over R1 plus R2. No? Nawawala yung R1, no? Because this is Vx over R1. Okay. And then I2b is equal to Vx over R2. So that's IS, okay, R1 over R1 plus R2. Okay. So that's one way of getting I1 and I2, no? But what's another way, no? Maybe a more straightforward way is by current division. So that's what I wanted to draw out from you earlier, no? Current division. Okay, if you did this by current division, okay, so this current divides into this resistor and this resistor. Okay, so I2b is straightforward. I2b is equal to IS times R1 over R1 plus R2. Okay, notice that that's exactly the same as this expression. Now, what about I1b? Notice that this current here should divide this way going down and this way going to the left, but that is opposite this direction. Okay, so this is going to be now minus IS, okay, minus IS times R2 over R1 plus R2, which is exactly what we got here. Okay, so you could have done it as suggested by one of your classmates using KCL, okay, which is this solution, or you could have just done it by current division. At any rate, okay, what is now your final value of I1 and I2? So finally, okay, I1 will be due to Vs acting alone plus due to Is acting alone. So I1 will be I1A plus I1B. Okay, so this is going to be Vs over R1 plus R2, okay, plus I1B minus Is R2 over R1 plus R2. And I2 is going to be equal to I2A plus I2B, which is, okay, what is I2A? You have Vs over R1 plus R2, okay, plus I2B, this one, Is R2, R1, Is R1 over R1 plus R2. So these are your final expressions for I1 and I2. Okay? Okay, so here's another example. Medyo mas mahirap ng konti but following the same principle. Okay. So determine the current that will flow through the 3 ohm resistor if the switch is in position A. So una, itong switch na to, okay, so this is a switch. This can either be in position A or position B. No? So una, yung switch nasa position A, and kukunin natin yung current na dumadaan dito sa 3 ohm resistor. Let me call this current I of X. Okay. So I want to determine the current I of X when the switch is in position A. And then I'm going to transfer the switch to position B, and I want to know what current will now flow through the 3 ohm resistor. By the way, no, why did I put this line here? No? Bakit ko linagay itong line na to rito? Can anyone answer me? Bakit hindi ko na lang basta ginawang ganito, no? Let's say may switch na ganyan, tapos ganyan. Bakit hindi ko na lang ginawang ganyan? And so forth. No? Can anyone answer? Anyone? Any thoughts? Any ideas? Bakit ko pa linagay ito? Can I call out someone? See Mr. Dino, no? Why did I put this Y here? No idea? Are you there?
No idea po, sir.
Sorry, I thought you were Mr. No? No idea. Okay. The reason is if I have this, hindi ba that's an invalid circuit? Kasi if I have this, you have a current, this is supposed to be an ideal current source, so there's supposed to be a current flowing there, pero walang pinupuntahan yung current, no? So pagka ganyan, theoretically, it's an invalid circuit. And I didn't want my circuit to look like an invalid circuit. That's why I put this wire here. So that when the switch is in position A, yung 6 amperes mo umiikot lang dito. And finally, when the switch is in position B, doon dadaan ngayon yung 6 ampere. No? But if you have a 6 ampere source that's just floating, na walang kinakabitan, then theoretically, that's an invalid circuit. Because there's supposed to be a current 6 amperes flowing, but where is the current flowing if it is open? Okay. So that's the reason. Okay, so how are we going to solve this? No? Okay, so with the switch in position A, so walang contribution itong 6 ampere circuit na to dito sa eyes of X. Ang nagko-contribute lang sa eyes of X would be my 81 volt source and my 9 ampere source. No? So with switch in position A, only the 81 volt source and the 9 ampere source contribute to eyes of X. Okay. So let's now try to compute for eyes of X. Let's call this eyes of X A. No? So with my 81 volt source, so I have here 6 ohms. I have here another 6 ohms. And then my 9 ampere source. Okay. Then I have here my 12 ohms. Okay. And then I have here my 3 ohms. So this is now, let me call this IXA. No? IXA, this is the current flowing through my 3 amperes with only the 81 volt source and the 9 ampere source working. No? So itong dalawa lang, this and this. This is not contributing because the switch is in position A. Okay, so how do I solve for IXA? What I can do, I can make this my reference. I assign, let's say, Vx to this node. No? So the Vx is the node voltage at this point. And then I apply nodal analysis. Applying nodal analysis, okay, what is my KCL equation? So KCL at Vx. Okay, so I Vx minus 81 all over 6. Yun. So I'm not going to ask you individually anymore, no? Kasi dapat experts na kayo ron. Vx minus 81 all over 6, okay, plus Vx all over 12 plus 3. Okay, that's the current flowing here, no? The current flowing here in this branch going outward is Vx divided by the sum of these two resistances, which end up being in series, 12 and 3. Okay, minus 9 is equal to 0. Okay? Minus 9 is equal to 0. And it's easy for us to solve for Vx now. No? You have Vx, this is 1 over 6 plus 1 over 15 is equal to 81.
Sir, excuse lang po.
Ano, no?
How about po yung 6 po dun sa baba?
You're only, yeah. Sorry. Very good. This is plus 6. 6 plus 6. Sorry. Thank you. No, thank you for pointing that out. Very good. No. So what is the current flowing here? Ano yung current flowing dito? Okay. Your Vx minus 81 volts. That would be the total voltage across this resistance and this resistance combined. No? So Vx minus 81 divided by 6 plus 6. Maybe to explain that further, no? Just para hindi lang kayo malito. When I have elements in series, I can rearrange those elements without changing the behavior of the circuit. So I can actually redraw this. Pwede ko i-redraw to. Okay, how could I have redrawn this? I could have redrawn that this way, no? Pwedeng 6, isa pang 6, tapos yung 81 ko, ganyan. I could have redrawn it that way. No? Thank you for pointing that out. So did you get that explanation? No? If I have elements in series, I can rearrange it. I can rearrange it in that branch, and it's not going to affect the current through the branch or the voltage across the entire branch. Okay, so here is so this is now 12, no? 1 over 12 plus 1 over 15. Okay, and if you solve for Vx, anyway, I'm sure my answer for Vx is correct. No, this is going to be 105 volts. Okay, so if I know Vx, I can now solve for Ixa. Ixa is Vx over 15. I know now Vx divided by 15. Okay, and that's going to give me 7 amperes. So what is 7 amperes? 7 amperes is the current flowing through this 3 ohm source with these two sources acting together. Okay, pag sinwitch ko yung switch from A to B, alam ko na kung ano yung contribution dito sa current na to with these two acting together. So the only thing that I have to compute now is the contribution of this current with this source acting alone. So with the switch, in position B, I can get contribution of ito, no, yung 6 ampere source to Ix if it is acting alone. So how do I make the 6 ampere source act alone? I make this act alone by suppressing this and suppressing this. How do I suppress this? I suppress this by replacing it with a short circuit, and I suppress this by replacing it with an open circuit. So ano magiging equivalent circuit ko, no? So my voltage, the 81 volt source, I replace with a short circuit. I still have my 6 ohms here, and then my 6 ohms here. My 9 ampere, I replace that with an open circuit. So open ngayon yan. Then I have my 12 ohms here. Here I have my 3 ohms. And now I have a 6 ampere source connected this way. Just to check, yes. A 6 ampere source connected this way. And let me call this now IXB. IXB. Now, how do I compute for IXB? Any suggestions? Any suggestions? Any suggestions? Clyde, may suggestion ka?
I suggest po current division din po.
Yes, current division seems to be the easiest, no? Current
Okay.
division. If you take a look, these two are in series. That's equal to 18 ohms. And then itong 6 ohm at saka 3 ohm are also in series, no? That's equal to 9 ohms. So I can actually redraw this. Meron akong 6 amperes. And then I have an 18 ohms. And then I have here a 9 ohms. And this is still IXB. IXB pa rin to, no? Yung current dito at saka yung current dito pareho. And so IXB is now going to be 6 amperes multiplied by 18 over 18 plus 9. Okay. And if I do that, I'm going to get 4 amperes. So finally, my IX is IXA. What is IXA? IXA is the 81 volt and the 9 ampere acting together plus IXB. IXB is the 6 amperes acting by itself. So ito nakuha ko kanina, this was 7 amperes plus 4 amperes, which will give me 11 amperes. Any questions? Any questions? So, simple lang superposition, di ba? Any questions with regard to superposition? Okay. Hirapan natin ng konti ang example. Okay. Use superposition to solve for V's of O. Okay, so this is what I want to solve for. I use superposition to solve for V's of O. Ang problema, I have two controlled sources. I have here a controlled voltage source, and I have here a controlled current source. No? This current source is controlled by the voltage across my 10 ohm, and this voltage source is controlled by my current flowing through my 5 ohm. Okay, when I use superposition, remember what I have to do sa superposition, no? I have to make each independent source act alone. I have to make each independent source act alone. So ang pinapa-act alone ko, yung mga independent sources, hindi yung mga dependent sources. So in this particular case, V's of O will consist of two components. One, with my 10 volt source acting alone, and the other with my 5 ampere source acting alone. No? So again, no, I have two independent sources no? That is a 10 volt and 5 ampere. No? So let me go back. 10 volt and 5 ampere, two independent sources. So V's of O will have two components. No? One due to the 10 volt acting alone, and the other due to the 5 ampere acting alone. So let's consider the 10 volt. Consider the 10 volt acting alone. So if I make the 10 volt act alone, anong gagawin ko rito? I will make the 5 ampere equivalent to, I will suppress this or make it equivalent to an open circuit. So ano ang magiging equivalent circuit ko? Okay. So this is going to be a 10 volt. Okay. I will have my, let's see, 5 ohms and then 20 ohms. I have a 5 ohm here. I have a 20 ohm here. Okay, this is I delta, and this is V of O. Let me call this V of OA. V of OA is due to the 10 volt source acting alone. So I have here a current source, tama? Yeah, 0.4 V of delta, where V of delta is the voltage across my 10 ohm. So this is my V of delta. And then here I have a controlled voltage source where this is 2 I's of delta. So it's a current controlled voltage source. No? And what happens to my 5 ampere source? That's now equivalent to an open circuit. No? So this is 5 ampere source suppressed. Ginawa kong open circuit. Okay. So I have to solve for V of O of A. Ito yung unknown ko, no? Kasi yun yung problem, no? Solve for V of O, no? I have to solve for V of O of A. That is V of O with the 10 volt acting alone. So anong tool ang pwede kong gamitin? No? When all else fails, ano, pag hindi mo na pwedeng gamitan ng any other technique that you know to simplify the solution, when all else fails, you always go back to the nodal analysis method. Nodal analysis. So let's say I want to use nodal analysis. I can assign this as my ground. Let me call this X and let me call this Y. Okay, and then I can apply now. I have in essence, I have 2 essential nodes, right? 2 essential nodes kasi walang nakakabit dito. So I can apply KCL at X and KCL at Y. So first, let me apply KCL at X. So anong KCL ko at X? Again, no, I'm not going to ask anymore. Expert na dapat kayo ron. So I have V of X. By the way, if you have any question, please stop me, just like what the earlier one of your classmates did. No? V of X minus 10 over 5. Yan yung current palabas dito sa X going to the left. And then I have, by the way, no? Sige. What is V of X? What is V of X? Anyone? Ano nakikita niyong equal sa V of X? Ito, no? Yung V of O of A. No? So, gamitin ko na yung V of O of A. No? So that I don't have to rewrite it anymore. V of O of A. No? V of O of A minus 10 over 5. Kasi yun yung V of X. Ano? Plus V of O of A over 20. So yun yung current dito. Okay. Minus itong current na to 0.4 V's of delta, okay, is equal to 0. Okay. That's KCL at X. KCL at X. Any question? Any question?
Sir, may ask lang po ako. Kapag po susundin po yung current direction ng I delta, kapag ginawa pong 10 minus V of A over 5, same lang po ba yung magiging sagot?
Yes, no?
Okay.
Yes.
Thank you po.
Kasi pag ginawa mo yon, pag sinundan mo yung direction ng I delta, okay, ano yung magiging sign nito? This is going to be minus Kasi papasok sa node, di ba? Hindi palabas. Right? So magiging minus 10 minus VOA over 5, no? Pareho yung dalawa.
Okay po, thank you po.
Nakita mo? Nakita mo?
Yes po.
Oh, okay. So pareho yung dalawa, no? Okay, so yun yung KCL at X, no? So dito, mag-KCL din tayo, KCL at Y. Okay. Ang KCL natin at Y, you have VY. So let's say VY is the node voltage here with respect to this point. Okay, VY minus, ano yung voltage dito? Yung voltage dito is 2 minus 2 I delta, no? Minus 2 I delta all over 10. Yun yung current na bumababa rito. Right? The current that goes down here is VY minus this voltage 2 I delta divided by 10, no? Which by the way, this is equal to V of delta. Pag tinignan mo, no? Which makes sense, di ba? Yung current dito sa 10 ohms, okay? No, I'm sorry. This is minus V of delta. Wait. Yeah, no, sorry. V of delta. Tama, V of delta. V of delta, no? Yung current dito sa 10 ohms, tama yung V of delta. Yung current dito sa 10 ohms is V of delta divided by 10. So ito lang yun, no? Okay, so yun yung bumababa rito. Okay? Plus 0.4 V of delta is equal to 0. So ano makikita nyo dito sa equation na to? Anong value ng V of delta? Do you notice anything? What will happen if I solve for V of delta here?
Magiging 0 po siya.
Yeah, that's right. Exactly, no? Pag sinolve ko dito yung V of delta, you're going to see that V of delta dito from here, V of delta is just equal to 0. Therefore, this is equal to 0. That is equal to 0. And therefore, I can easily now solve for V of O's of A. No? So from here, I can solve for V of O's of A. V of O's of A, 1 over 5 plus 1 over 20 is equal to 10 over 5. No? Or it's equal to 2. Right? And if I solve for V of O of A, that's just going to be 8 volts. That's going to be 8 volts. Any questions? Any questions? So ito yung V of O due to my 10 volt source acting alone. So ngayon, ano yung next step, no? Next step, I consider now just my 5 ampere source acting alone. So consider the 5 ampere source acting alone. So ang voltage source ko ngayon is going to be a short circuit. Short circuit ito. Ito yung 5 ohms ko. Ito yung 20 ohms. Okay, ito yung ginawa kong reference kanina. I will continue to make that my reference. Okay. This is 0.4 V of delta. This is 2 I's of delta. Ano nga ba yung I's of delta? Ito, no? This is I's of delta. This is now going to be V's of O, B. V's of OB is due to my 5 ampere source acting alone. And then I have my 10 ohms here. This is my V's of delta. And this is my 5 ampere. Again, no? Let me call this X and let me call this Y. Okay. Just to make sure that you're still awake, no? Can I ask Albert to tell me what my KCL equation is at X?
V's of X over 5 po.
Yeah, but what is V's of X?
It's V of O of B
Yeah, V's of O of B over 5. Okay.
over 5 plus V's of O of B over 20
Okay.
minus 0.4 V of delta.
Okay, that's right, no? Is equal to 0. Is equal to 0, no? Okay. Can I ask Clyde to tell me what my KCL at Y is?
0.4 V's of delta.
Okay, 0.4 V's of delta.
Plus V's of delta minus 2 I's of delta over 10.
I'm careful, no?
Aba.
V's of Y minus 2 I's of delta over 10, no? But V's of Y minus 2 I's of delta, yun na yung V's of delta mo eh. So, so what is the correct expression?
So it's V sub Y po minus 2
Sige.
I's of delta over 10.
Okay. Which is equal to, tama, no? Sige, sulat kayo, no? V's of Y minus 2 I's of delta over 10, no? But what is this?
It's also V sub delta po.
Yeah, that's V sub delta, no? Ito yung V sub delta. Kasi ang current na bumababa rito, no? Ang current na bumababa rito is the voltage across this resistor divided by the resistance. And the voltage across the resistor is already V sub delta, no? So yung current dito is just V sub delta divided by 10, no? But anyway, you're correct, no? Sige, tuloy mo.
Okay po. Minus 5 equals 0 po.
Minus 5 is equal to 0. Okay? So from this equation, okay, madali na nating masosolve for V sub delta, no? Kasi yung V sub delta multiplied by 0.4 plus 1 over 10 is equal to is equal to 5. No? Diba? So you're going to get V sub delta is equal to this is going to be equal to 10 volts. V sub delta is equal to 10 volts. No? So, i-plug na natin ngayon to dito. Diyan. Okay. So now I can solve for V sub O of B. So from this, I have V sub O of B 1 over 5 plus 1 over 20 is equal to 0.4 times 10. Times 10. So madali ko ngayon masosolve for V sub O of B. V sub O of B is just going to be equal to, I already solved it, 16 volts. So finally, what is V sub O? V sub O is equal to V sub O of A. So ano yung V sub O of A? That is with the 10 volt source acting alone plus V sub O of B. V sub O of B is the 5 ampere source acting alone. No? So ito is 8 volts. Ito is 16 volts. So this is just going to be equal now to 24 volts. Any questions? Any questions? So ang key dito is this, huh? When you use the principle of superposition, you make each independent source act alone. No? The dependent sources, you cannot make them act alone because they are dependent on other sources. So it is the independent sources that you act alone. No? I see this very often, mga mali ng estudyante, okay? They think that there are 4 sources here and they make each source act alone, which is wrong. No? It is each independent source acting alone. So I hope those of you that are here right now, you're only 4, no? But I hope you do not make that mistake when it comes to an exam or solving a problem. And that's why I'm emphasizing that right now. Okay. So let's move to the next topic. No, this is a relatively easy topic. Okay. When we talked about equivalent circuits before, so we talked about equivalence dati, ano? Equivalence. Ano yung sabi natin, no? We said that you have circuit A, for example, you have circuit B. Okay. So let's say this is X and Y. This is also X and Y. Okay. Then I have another circuit. Let's say circuit C. Okay, let's say this is A and B. Ano yung significance ng equivalence? Kung ito, ikabit ko rito, ito, ikabit ko rito, hindi malalaman ng C kung ano yung nakakabit sa kanya, whether it is A or B. No? So here, no, if A and B are equivalent, C cannot distinguish. C cannot distinguish what is connected to it, whether it is A or B. And we studied equivalence before for resistive networks. So pinag-aralan natin yung equivalence na yung laman nitong A o yung laman nitong B, puro resistor lang. No? So ngayon, ano kung may mga sources? What if A or B have sources in them? So that's what we're going to take up next. No? And the first thing that we're going to take up is source transformation. And then in the next meeting, we're going to take up Thevenin equivalent and Norton equivalent. So today, let's just take up source transformation. So this is the idea of source transformation. No? An ideal voltage source with a resistor connected in series can be converted into an ideal current source with the same resistor connected in parallel and vice versa without affecting the behavior of the rest of the circuit. So, for example, I have here a voltage source, an ideal voltage source. Okay. This is connected to it. This circuit is connected to it. What I'm going to get, I'm going to draw this current and I'm going to develop this voltage across my circuit. No? Okay, I can find a corresponding current source with a resistor connected in parallel such that with respect to this circuit, it will feel exactly the same thing. It will feel exactly the same thing. Hindi niya malalaman kung ito yung nakakabit o ito nakakabit. Ano? In other words, the voltage that will be developed across my circuit and the current that will be drawn from this combination will be the same as this. So that is source transformation. No? If I want to convert this to this, then all I have to do is itong current source na to, I compute as V sub S divided by R sub S. So that's converting the voltage source to the current source. On the other hand, if I wanted to convert this to this, pabaliktad naman, then the voltage should be this current source multiplied by Rs of S. No? Multiplied by Rs of S. Yun yung source transformation. And it's very easy to prove this. Yeah. Just to illustrate, no? So dito sa left side, okay? If I perform KVL here, Kirchhoff's voltage law around this loop, I'm going to get this voltage V is equal to V of S minus I times R of S. So I'm going to get V is equal to V of S minus I times R of S. No? That's performing KVL around this loop. Dito sa right side naman, if I perform KCL at this particular node, okay, what am I going to get? I'm going to get this current I, the current I, is equal to the current I's of S minus the current flowing through R's of S. But what is the current flowing through R's of S? The current flowing through R's of S is V divided by R's of S, minus V divided by R's of S. Okay, if I plug, no, so if this is going to be equivalent, then V and I should be the same, no? So V and I should be the same. So I can plug this I into this. No? Hold it, no? I is equal to I's of S. Yeah, minus V over. Okay. So what will come out, no? So V is equal to V of S minus I's of S minus V over R's of S multiplied by R's of S. No? Yeah. Yeah. So what will happen, no? This is V of S minus I's of S, R's of S plus V. No? So this cancels, right? And I'm going to get V of S is equal to IS times R's of S, no? Which is exactly this equation. In other words, if I'm converting from a current source to a voltage source, I can just multiply my current source with R's of S and I get the value of the voltage source. On the other hand, if I'm going from a voltage source to a current source, then the value of my current source will just be V of S over R's of S. No? So it's in the dalawang equation, which is consistent with this. Okay. So actually very trivial. No? So let's take an example. Always best to illustrate by means of an example. So solve for the power associated with the 6-volt source. Solve for the power associated with the 6-volt source. So if I want to get the power associated with the 6-volt source, ang pinaka maganda if I can convert this to an equivalent circuit. So convert to an equivalent circuit. Kasi ang kailangan ko lang naman makuha para makuha yung power na ano no na associated with this is to be able to determine what the current is being supplied by the 6-volt source, no? So if I can simplify this into a simple equivalent circuit, then I would easily be able to solve for the current being supplied by the 6-volt source. Okay? Now how can I do that? How can I simplify this? So remember, I have to preserve these 2 points. So dapat hindi mawala itong 2 point na to, no? Because that is where your 6-volt source and the 4 ohm is connected to. So I work from the back. Notice that itong 40 volts, I can combine with the 5 ohms. I can convert this to a current source. Itong 40 volts with the 5 ohms, no? I can convert that to a current source. Ano magiging value ng current source? Anyone? Ano magiging value ng current source? Can I ask Can I ask Albert?
Sir, wait lang po. Wala pa pong ID.
No. Okay. Can I ask Kale?
24.
Why 24? I'm curious, no? Why 24? No, what I want to do is this one, ano? Let me use a different. Ito. I want to convert this to a current source. Just these two.
O 200 po.
No.
200.
Palagay ko baliktad yung formula mo.
Ay.
No. So I want to compute for i's of s. Ito, I want to compute for i's of s. So ang formula ko is i's of s is v's of s over r's of s, ano? So ang v's of s ko is itong 40. My r's of s is 5. So ano yung value ng current source ko? It should be 8. Okay? Did you get that? Okay. So ito ngayon, okay? I will redraw that. That is now an 8 ampere. This way, 8 ampere. The current going from plus minus. Tapos yung resistance ko, dati-dati naka-series, ngayon magiging naka-parallel na. No? So this is going to be my 5 ohm. No? Okay. So what are these 2 points? These 2 points is this point, itong point na to, at saka point na to. So pwede ko ngayon ikabit uli the rest of the circuit. So I have now my 20 ohm here. This is my 20 ohm. And then I have my 6 ohm here. I have my 10 ohm here. I have my 30 ohm. And then 4 ohms. And then the 6 volts. Okay. I converted this to a current source. Okay, why is that a good idea? Ano pwede kong next na gawin? Clyde, what can I do next?
I think pwede na
Any
pong,
simplification that you can do?
parallel na po yung 20 ohms and yung 5 ohms.
Exactly, no? Nung ginawa ko yon, itong dalawa ngayon naging parallel na. Parallel na itong dalawa, no? So ito ngayon, itong dalawa in parallel, so 20 in parallel with 5, that will give me 4. That will give me 4. Okay? Ngayon, ang gagawin ko, ito, I convert again to a voltage source. So I convert this again to a voltage source. No? I have an 8 ampere source in parallel with a 4 ohm. Ano magiging value ng voltage source ko? Can I ask sige, Albert? You weren't ready earlier. Ano magiging value ng
Yes.
voltage source ko?
32 po.
32, that's right, no? So dito, with respect to this point and this point, I now have a 32 volt source. Tapos itong 4 volt, 4 ohm na to, ngayon will be in series. Okay? So that's what's going to happen now. So, andito ngayon yung 6 ohms ko. Andito ngayon yung 10 ohms ko. Andito ngayon yung 30 ohms. Andito ngayon yung 4 ohms. And finally, yung 6 volts. Okay, so now what can I do? Anong resistances ang pwede ko i-combine? Clyde, what resistances can I now combine?
Pwede na po i-combine yung tatlong in series na resistor po.
That's right, no? Itong tatlo pwede kong i-combine, no? Remember what I said earlier? When you have elements that are in series, you can rearrange those elements and they are not going to affect the performance of the circuit, no? So itong tatlo pwede kong i-combine into a single resistor. So if I combine that into a single resistor, ang magiging in series dito sa 32 volts na to will be 20 ohms. Okay? Which I can now convert to a current source, no? So ito ngayon, I can convert this to a current source. What is that current source? I have 32 divided by 20. Okay. So meron akong current source, 32 divided by 20. Okay. And then I have 6 plus 4, 10 plus 10, 20. And nakaparallel ngayon to sa 30 ohms. And then here I have my 4 ohms. Then here I have my 6 volts. Okay, so itong dalawa ngayon nakaparallel. Okay, ano yung magiging parallel combination nitong dalawa? 30 ohms and 20 ohms. That will be 12 ohms. No? This is 12 ohms. So finally, what is my final circuit? I'll have 6 volts. Okay. I have here my 4 ohms. Okay. Itong 12 ohms, I can convert back to a voltage source. Okay, so I'm going to have my 12 ohms in series. And then my voltage source, that's going to be 12 multiplied by 32 over 20, which is going to be 19.2 volts. 19.2 volts. Okay, so ano magiging power associated, kasi yung problem, no? What is the power associated with my 6 volt source? All I have to do is get this current. What is I? So dito, I is equal to 19.2 minus 6 divided by 16. Okay. 19.2 minus 6 divided by 16. This is going to give me 0.825 amperes. Okay, and P, 6 volts, is equal to I times 6, which is going to give me, so I'll just give you the answer, 4.95 watts. Question, tama ba yung sign ng watts ko? Is the sign correct? Ano ibig sabihin pag positive yung power? Ano ibig sabihin? Do you remember? Can I ask Mr. Norio, Shaq? What does it mean when the power is positive? Yeah, somebody answered through the chat, ano, na it is dissipating. It is dissipating, or it is absorbing power. No? So this 6-volt source is actually absorbing power. No? That is, it is positive because we follow the passive sign convention. No? Passive sign convention, if your power is positive, that means it is absorbing. So although this is a source, it is receiving power instead of delivering power. Any questions? Okay, any questions? I want to discuss two special cases. The two special cases are this: when you have a resistor directly in parallel with a voltage source, and the other special case is when you have a resistor directly in series with a current source. In both of these cases, itong Rs of P and itong Rs of S will have no effect on what is connected dito sa A at saka B. Will have no effect on what is connected sa A at saka P. No? Why is that so? No? Rs of P is not going to affect any of the currents outside of the nodes that it belongs to. No? But because the voltage from this point to this point will always be V's of S, no matter what the value of Rs of P is. Wag lang siya maging zero. No? Wag lang siya maging zero. The voltage across this point and this point will always be V's of S. So it will have no effect on the currents that will flow to the right. No? On the other hand, itong Rs of S will have no effect on the voltages here on the right side. It will only affect the voltages within this branch. So for the purpose of circuit analysis, no, if we're only interested in the behavior of the circuit dito sa A at saka B, I can take this out and I can take this out. Pwede ko siyang tanggalin. Okay, I have an example for that. We don't have that much time to discuss this example, no? But let me just outline the solution. So I want to solve for V's of O by simplifying the circuit. Okay. Now, you might see this voltage source, no? Tapos makikita nyo, wala pa lang resistor naka-series sa voltage source na yan, so I cannot convert it to a current source, no? Because you can only convert this voltage source to a current source if there's a resistor in series. This is not in series. Right? Because remember the definition of series, at their point of interconnection, dapat nothing else is connected. Ang problema, meron nakakabit itong 125. No? However, this resistor is not going to affect the currents flowing dito sa kanan nito. No? So I can actually remove this for purpose of determining the currents flowing here on the right. And this resistor is not going to affect the voltages outside of this particular branch. So I can also actually remove this. So for computing for V's of O, no, ang magiging equivalent circuit ko, ganito. 25 ohms. So tinanggal ko na itong 125. Tatanggalin ko na yung 10 ohms. Okay. So I just have here now 100 ohms. And then 5 ohms and 15 ohms. Okay. So how do I solve for V's of O? Okay? What do you see can I do right now? Anong pwede kong gawin? Any suggestion? Any suggestion? Yung hindi pa sawang matawag. What can I do? Medyo pagod na ba kayo? Anyone? Yeah, maybe you guys are tired already, no? Anyway, let's see, somebody in the chat, no? Yeah, that's right, ano? Ito pwedeng gawing current source. Okay, so sige, let's do that, no? So gagawin ko tong current source. So what is the value of my current source? That's going to be 250 divided by 25 or 10 amperes. No? Tapos itong 25 will be in parallel. Okay. And then now I have an 8 ampere. And then I have my 100 ohms, 5 ohms, 15 ohms, and then this is my V sub O. No? Okay. Anong pwedeng gawing next? What can I do next? Yeah, Mr. Norio, no? Since naumpisahan mo na, what can I do next?
Going voltage source po ulit siya.
Ito, gagawin mong voltage source ulit. Anong ginawa mong current source tapos ibabalik mo sa voltage source? No. Think
Tama
about
po
it
ba
a
yun,
little
sir,
bit.
yung i-add yung 8 and 10?
Yes, you can do that. You can do that. Good. But algebraic, no? It should be algebraic. Sorry, no? Yung 8 pala, pababa yung 8, ano? 8 amperes. No? Remember we took up current sources in parallel? Right? Di ba? You can combine current sources in parallel. So you can combine the 8 and the 10, no? So magiging isang current source na paganyan. Ano yung value nito? This is going to be 2 amperes. Okay? So, okay, you can do that. 25, 100, 5, and 15. Okay, we don't have that much time anymore. Okay, here's what I'm going to tell you, no? These are all in parallel. And they can be combined with while preserving V sub O. Right? Kasi V sub O is actually the voltage between this node and this node, no? By the way, these two are just in series. So V sub O is the voltage between this and this. So kahit na i-combine ko itong tatlong to, hindi mawawala yung V sub O, which is remember what you should be very careful about whenever you do circuit simplification. Pag nag-circuit simplification ka, dapat hindi mawala yung variable na hinahanap mo. No? But that's okay kasi pag kinombine mo itong tatlong to, nandun pa rin yung V sub O. You're preserving the terminals across which V sub O is being measured. No? So you can combine all of those three. No? So in effect, magkakaroon ka ng 2 ampere source dito you're going to have one equivalent resistance, and that's still going to be V's of O. So it's now very easy to determine V's of O. Okay, V's of O is just equal to 2 amperes multiplied by R Q. Okay, what is REQ? REQ is 1 over 25 plus 1 over 100 plus 1 over 20. Yun lang yung value ng REQ. And I think I have the answer to that. That is 10 ohms. No? 10 ohms. So V of O is just 20 volts. Okay, that's all I wanted to discuss this afternoon. Are there any questions? No? Any questions? Okay, so if there are none, then we'll see each other again on Thursday, I guess. No? I'll stop the session as soon as the last person leaves, so that in case you want to ask questions, you can still ask questions.
Thank you po, sir.
Okay.